Hi friends. This video is on how to write an equation when you might not know some of the key points of a parabola or a quadratic. So we're going to write a quadratic equation, but maybe we just have 3 points somewhere along the parabola. They're not necessarily the vertex, not necessarily the roots or the x-intercepts. And that can make it a little bit trickier to formulate an equation. So let's take a look at just 3 points. There's these 3 points. I don't know where they are. I don't know if one of them is the vertex. That, of course, would help me a lot because then I could plug it into vertex form and just solve for whatever the missing a value would be. I don't have the roots of this equation, so I can't write it in factored form or intercept form and then solve for the a value. So I'm really going to need to come up with another strategy here to figure out what is the equation of this quadratic formula. So assuming that we know that these are all along a parabola somewhere, maybe we've been given a graph or maybe we've mapped it out. So we know it's going to be a quadratic equation. I have a certain amount of information here, right? I've got an x value and I know that it maps to a y value. And I actually have 3 of those, right? 3 of those situations. So I'm going to take each of those situations and see if I can figure out a way to evaluate an equation for it or a function for it. So let's take a look at this first point, right? I've got an x value of 1, a y value of 3. I'm going to see what I can do with it, see what happens if I plug that in. So let's take that 3. That replaces the y equals a times the x value is 1 squared plus b times the x value is still 1 plus c. So in other words, 3 is equal to 1a plus 1b plus c. Okay. Well, that's one equation, but I've got 3 unknowns. So if I want to have any hope at solving this, I'm going to have to get a couple more equations so I can start resolving some more of these unknowns. But that's okay. I've got a couple more points. Let's see if I can write some more equations. So here this point has an x value and a y value. So I'm going to plug those in to an equation. So y, which is 3, is equal to a times 0 squared plus b times 0 plus c. In other words, 3 is equal to c. The equation for the third point, x and y, is 5 is equal to a times 2 squared plus b times 2 plus c, which is going to be 4a plus 2b plus c. Well, basically, if I take a step back, what I really have here is a system now of 3 equations and 3 unknowns. I have this equation here. I have a plus b plus c is equal to 3. I have, and I'm going to write this a little strangely. I'm going to write this as 0a plus 0b plus c is equal to 3. And here I have 4a plus 2b plus c is equal to 5. Well, this looks like a system of 3 equations. And since this must be a system of 3 equations, I could write this as a matrix equation. And I could use matrices to solve for my 3 unknowns. So here my coefficient matrix, my first row would be 1A, 1B, 1C, so 1, 1, 1. My second row would be 0A, 0B, 1C, so 0, 0, 1. And my third row would be 4A, 2B, and 1C. So there's my coefficient matrix. My variable matrix is ABC. And my solution matrix is 3, 3, and 5. So I'm going to use this matrix equation to solve this system of three unknowns. Let's take a look ahead. So here's my three equations that form my system. Oh, I kind of missed. Let's try that again. And here I wrote it in my equation. Here, because I had my solutions on the left-hand side, I put my solution equation on the left-hand side. So remember that the first step to solving a matrix equation is to find the inverse. I should say we want to find the inverse of our coefficient matrix. And I did that on a graphing calculator. So I plugged it into the graphing calculator and asked for the inverse equation, and I got this lovely inverse of the coefficient matrix. Now, remembering that this is a 3 by 3 matrix and this is a 3 by 1 matrix, and these inside dimensions have to match in order for me to multiply, I made sure to put the inverse matrix on the left-hand side of my solution matrix. And of course, whatever I do on one side, including putting it on the left-hand side, I do on the other side of the equation. So these, the inverse and the coefficient matrix cancel down to the identity matrix, which cancels them out. And I'm left with the solution of this multiplication problem here, which is 1, negative 1, 3, is equal to ABC. Which means that in my standard form of a quadratic equation where y equals ax squared plus bx plus c, I now have the three coefficients. I know that y is equal to 1 x squared plus negative 1x plus 3, or the way I would really write it would be y is equal to x squared minus x plus 3. And that is the standard form of the equation with those 3 points. I can then use that equation to graph my parabola. First, of course, I'd like to graph those 3 points. So 1, 3, 0, 3. The vertex has got to be somewhere in between there, right? And 2, 5. Looking at my equation, I know that this is going to open up because my a value is positive 1. But I still need to find the vertex. So remember that the vertex is along the axis of symmetry, and the rule for the axis of symmetry in standard form is x is equal to negative b over 2a. So in this case, that's negative 1, which is positive 1, over 2 times 1, or 1/2. So here at x is equal to 1/2, I have my axis of symmetry. Bring that in. And then I'm just going to evaluate that function at 1/2 to find the value. And I did that here. So 1/2 squared was 1/4. 1/2 times negative 1 was negative 1/2 plus 3. So 1/4 minus 1/2 is negative 1/4 plus 3 is positive 2.75, or positive 2 3/4, which is right here. Well, maybe a little higher. Oops. Okay. And now I could also reflect this point. I have this point here, 2, 5. which is 1.5 from the axis of symmetry. So coming over, I would have another point at -1, 5. And I could just go ahead and graph this parabola. Okay. So that is how you can write the equation from 3 points, and then how you can follow up to graph it. I hope that that helps, and I look forward to answering any questions next time I see you in class.